Good morning. Today we're going to look at how to solve a system of equations using the substitution method. We also called this the equal value method in the past. Now, the reason we can use this is very basic. I know that if this is y and this is y and they're the same value, then whatever those things equaled must also be the same value. So in this case, since y is 3x plus 2 and y is negative 2x plus 27, we know it must be true that 3x plus 2 has to also equal negative 2x plus 27 because they equal the very same things. Now, this leads us to an interesting idea that we can simply solve a basic equation by adding 2x's to both sides to get 5x plus 2 equaling 27, and subtracting the 2, I was trying to get ahead of myself there, to get 5x equaling 25, and dividing by 5 to get x equaling 5. But we also know that the system of equations solution is a point in space where these two things intersect. So having just the x doesn't do me much good. Instead, now I need to take one of my original equations. I'm going to pick the top one because it doesn't have a negative, and I don't like negatives if I don't need to use them. And substituting back, since x is 5, I can say that the y value has to be 3 times 5 plus 2, or 15 plus 2, which is 17. So if I end up with y equaling 17 and x equaling 5, it ought to work for the other equation as well. So the last thing I do before I write my final answer is I check it in this equation. If y is 17, then 17 should equal negative 2 times 5, or negative 10 plus 27. And that's true. 17 is negative 10 plus 27. I have a correct answer. In fact, I have the only correct answer. Now, in the end, we'll write our answer as a coordinate pair, 5, 17, and that's our solution.